ChatGPT can hold a conversation, recommend your next show, or find the right document in seconds, and none of that works without a vector database sitting underneath it. If you're building anything with AI right now, this is the piece most people skip over. A vector database stores and searches data by meaning, not by exact words or IDs. Here's the analogy that makes it click. Imagine a library where books aren't organized by title or author, but by concept. Everything about grief sits near each other. Everything about rebellion clusters together, even if those books never share a single word. A vector database works exactly like that. You search by idea and it finds what's closest in meaning. Underneath, it's doing this by storing data as vectors, long lists of numbers that mathematically represent meaning, and finding which ones are geometrically nearest to your query. Keyword search breaks the moment language gets messy. Search heart attack in a traditional database and you might miss a document that only says myocardial infarction. These mean the same thing. A keyword index doesn't know that. A vector database does. This matters in real products. AI chatbots that need to reference your company's internal docs. Recommendation engines that need to suggest content based on what a user actually engaged with, not just what they clicked. Medical search tools where missing a synonym isn't a minor inconvenience, it's a liability. The teams that skip this end up with an LLM that confidently answers questions using outdated training data because it has no way to access what it actually needs in the moment. That's the failure mode, and it happens constantly. When you feed text or an image or audio into an embedding model, it converts that content into a vector. Think of a vector as a coordinate in very high dimensional space. OpenAI's text embedding ADA0-2 model, for example, outputs vectors with 1,536 dimensions. Each dimension captures something about the meaning of the content. When you store those vectors in a database like Pinecone, Weaviate, or pgvector, which is a Postgres extension, the database indexes them using an algorithm called HNSW, which stands for Hierarchical Navigable Small World. You don't need to memorize that name. What it means is, the database builds a graph structure that lets it search millions of vectors in milliseconds without comparing every single one. It's approximate nearest neighbor search, trading a tiny bit of precision for enormous speed gains. Here's the sequence when you run a semantic search query. Your query text goes through the same embedding model. That produces a query vector. The database then finds the vectors nearest to it by calculating cosine similarity, which is essentially the angle between two vectors in that high dimensional space. Small angle means similar meaning. Large angle means different meaning. This is exactly how RAG pipelines work, retrieval augmented generation. You store your documents as vectors, retrieve the most relevant ones at query time, then pass those into an LLM as context. The model doesn't need to have memorized your data. It just reads it fresh right then. If this is the kind of thing you want to actually understand, not just use, Stack Future covers one concept like this every week. Say you're building a support chatbot for a SaaS product. You have 800 help articles. You want the chatbot to answer user questions based on those articles, not based on whatever GPT-4 was trained on 2 years ago. You run each article through an embedding model. You store the resulting vectors in Pinecone, tagged with the article ID as metadata. When a user asks, "Why can't I export my data?" your app embeds that question, queries Pinecone for the top 5 nearest vectors, retrieves those 5 articles, and passes the text into GPT-4 with a prompt that says, "Answer this question using only the following documents." No fine-tuning, no retraining. The model answers accurately because it's reading the right content in real time. If Pinecone returns irrelevant results, the fix is usually the embedding model, a mismatch between how you embedded your docs versus how you're embedding queries. Switching to a task-specific embedding model like Cohere's Embed v3 often resolves it immediately. Vector databases are what give AI systems memory that's actually useful, the ability to find relevant information by meaning, not just exact match. That's the thing to hold on to. Next up, how AWS free tier actually works, and why developers keep getting surprise bills even when they think they're staying free. If this video earned it, hit the like button. It genuinely helps.